All right, so our last unit that we are going to do, we should do a unit 7 on matrices, but there is no time for that. So our last unit that we are going to do is going to be a preview to the first unit of calculus. So limits are the foundation of all of calculus, and if you take calculus, if you take it with me or if you take it in college, your first unit will be on limits. And like if you take it with me, I know for sure that we go in a lot more depth than we're going to go in for just what we will do in this class. But I think it is helpful for you guys to see a glimpse of that first unit, because otherwise, if you go into calculus, you will, if you have not done this, then you will be thrown into day one something new, which usually does not happen in your math classes. Usually you start with something you've kind of seen it some before. So I think it is helpful, particularly since some of you may be taking this first, this Calc 1 at, I think they're doing a call for letting them know this lockdown has ended. So I think it's helpful to have seen it a little bit before you take calculus if you are headed that direction. It was kind of up in there. I could skip limits or I could skip matrices. I think limits are going to be more helpful to you as you go forward. Although I'd like to do both if time would allow, but it just won't. So we'll do this section today. We'll do graphs tomorrow, and then we will not do anything on Wednesday because it's just a fun day. When we come back, we'll look at the algebraic and some limits at infinity, and we'll probably test Friday of the week when we come back, which will leave us for just like a day overview, and then we'll have our exam. Most of you do not have to take the exam. For those of you that do have to take the exam, I'm going to try to have at least a little bit of exam review up before we go home for Christmas, so that you can be looking at that, because we will not spend a lot of time in class reviewing for the exam because very few people have to take it. So we're not going to spend large amounts of time. I can't tell you for sure until we have taken the Unit 8 test, because it depends on your grade as well. But I have not checked absences within the last like 3 or 4 weeks, but it is 3 unexcused absences and an A, 2 and a B, 1 and a C. And if you have a D or below, you have to take it. So based on where your grade is at, you can check how many unexcused absences you have. I'll go through and look at them. And Unit 8 test will change your grade some, and 6 isn't in there right now because it wouldn't go in. So it'll change your grade some, but if you're pretty solidly in a B range and don't have any unexcused absences, you're pretty safe. There, yes.
I have like 2 or 3 excused absences, and they still show up on my power school.
Yes, they will. They will show up.
But they won't count for anything.
They won't. They don't count for exemptions.
Okay.
Right, they count for your attendance, but they don't count for exemptions.
Okay.
Yeah.
Do tardies count towards absences?
Yes, if you have 3 unexcused tardies, they count as an unexcused absence. So whenever you're looking at that for exemptions, every set of 3 is going to be like an unexcused absence. So if you didn't have any absences, but you had 15 tardies, you would still have to take your exam.
So if you have like 2 absences and 2 tardies, you're all right.
Yeah, you're cutting it awfully close. If you have an A. If you have an A. Yeah. You're cutting it awfully close if that's the case. And it's unexcused absences, so if your absences are excused, it's not an issue. It's only unexcused.
I don't have 2 absences and 2 tardies.
He's just going with theoretical.
I have 1 absence and 0 tardies. So.
Yeah, but
Thank you,
theoretically. tardies are not a problem in this class, but second period they're typically not. However, you know, and I will help you guys figure out also whether or not you are borderline, whether or not it would be possible for you to take the exam and do better. Because if you have, you know, if you have like an 85, you are not going to be able to bring your grade up enough with the exam that it'll work. But if you're like 88, 89, it might be. But I can't tell you that for sure till we've taken all of our tests because those will affect our grades too. It will not hurt you. As long as you're exempt, yeah. Yeah, I just won't count it and it'll just say what it was. Yeah. So if you're in that range where you're close, you want to go ahead and take it because it can't hurt you. And, you know, I mean, it's just teacher made. It's an hour and a half. It won't be that big a deal. But if you do bad, it won't count against you at all. So it can't bring you down if you're exempt. Okay. All right. So, all right, limits. Okay. This is, believe it or not, the informal definition of a limit. It sounds a little bit complicated, but there are much more complicated definitions of limits. And the idea, in general, is pretty straightforward. Oh, I have not done a sentence. Let me do that. If there is a number, L, such that the value of f of x gets closer and closer to L as x gets closer and closer to a number A, then L is called the limit of f of x as x approaches A. Okay, so let's think about this. Okay, I'm going to look at the notation here, and then I'm going to draw you a graph so we can kind of see what some different scenarios would be. So the notation that you see here, this is the limit. This underneath, typically it doesn't have the double bar arrow. It's just a single arrow, like a normal arrow, but it wouldn't let me type that because it wasn't an option. So limit, underneath limit, it's going to say x, this arrow, A. So x approaches A. A is typically a number. So it's like x approaches 1, x approaches 0, x approaches negative 52. Or it may be infinity or negative infinity. Okay? And then you'll have a function here, f of x. It may just say f of x, or it may have an equation for f of x. So it might be like x squared plus 3x plus 7. Okay? So, to think about what is going to happen here, let's think about, I think it helps to look at a graph here and an example with some numbers in it. Okay, and we're going to focus mostly on tables today, but we'll look at graphs some tomorrow. So this is our x-axis. This is our y-axis, but we could also call it f, because f in this particular case would be your y values, right? Because we're calling this f of x. So this is f of x here. So you may have a particular function. It may look like whatever. And you have a value on the x-axis called a. So if I put that right here, if I say this is a. Remember, it's going to be a number, so it might be 2, it might be 7, it might be 15. So what's going to happen here is we will look at the values of this function as our x-coordinate gets closer and closer and closer to A. Now this one is really straightforward because it's just a graph. So as we get closer and closer and closer to A, from either side we go to this point right here, and that is a point. The x-coordinate is A. The y-coordinate, we could call it f of A, or they say this is equal to L, so we could call it L right here. That'd be your y-coordinate. Says what your limit is equal to. So as you get closer and closer and closer here to this value, your y-coordinate gets closer and closer and closer to L. Okay, this is particularly going to be important whenever we have graphs where we have holes in the graph, or we might have vertical asymptotes, or things other than just a basic graph. Okay. Today we're primarily going to look at tables for this. But first we got a little more notation. Let me get notation first. So we also look at limits from each side. Okay. So if we look at our notation here for this first one, we've got the limit as x approaches a, and then we got a plus behind it. So it's not positive a, it's got a plus behind it. This means the limit of f of x as x approaches a from the right. Okay, so if we see this with the plus sign right here behind the a, that means that we are only looking at the values that fall on the right-hand side of whatever value a is, because a is going to be a number. So if that was 3 and we're approaching it from the right, we'd pick numbers bigger than 3 and try to get close to 3 there. Here on the second one, we have a negative behind our a. And it's behind, not in front. If it's in front, it just means negative a. But this one's behind, so what do you think that is going to mean for this one? Approaches from the left. So same expression here, the limit of f of x as x approaches a from the left. If you have an expression like this, where you do not have a plus sign or a minus sign behind your value here, then that means from both sides. Right, so if we do not have a plus or a minus behind our value right here, that would just mean that we're looking both left and right. What we'll see here is in order for the limit from both sides to exist, your limit from the left and your limit from the right have to be the same value. So you can get, this particularly might happen with like piecewise functions, where you've got maybe a function that looks something like this. If this right here was my a, from the right-hand side, I would approach that point. From the left-hand side, I would approach this point. So my limits from the left and the right can exist, but my limit at a from both sides does not exist because those numbers are not the same. Okay, questions so far? All right, so today we're in particular going to be looking at tables. All right, so if you guys will get your calculators for me, close out some of this other stuff I got open here. So I'll get to my calculator. All right. And Desmos will do this stuff as well, so you can use Desmos when you're at your house if you don't have a calculator. We're going to use the calculator because on the test I may restrict you to calculator because Desmos has some of the other problems we're going to do. Desmos might make it too easy for you, or you at least may have some Desmos restricted questions. So I'd like for us to be able to do this with the calculator. So if you go to y equals, we're just going to type in this equation that we have here. You need to make sure you put parentheses around your x plus 3 on the top. And then parentheses around the bottom. And enter that in your y1. Look at yours. Go back to your main screen. Type X. Try, I think it's the number. There's a way to go to, Larry, how do you clear out the X if you've got it stored as a number? Oh, second plus sign 712 if you want to do that. Second plus sign 712.
We just do 7 plus 7.
That's what I said. Second plus sign 712. I just mean a plus sign instead of instead of just saying plus. No, not the sign button. No. Yeah. No. I've taken you to a higher level of math where you hear the word sign and now you think of tricks. So that's a good thing, maybe. Yeah. I did not mean sign. I did not mean the sign button. So that'll clear everything out. There's a way to just clear the X out. I don't usually store my X's values just for that reason, but I think it may still graph it. All right. So we want to see the table. So if you just hit second table right now, notice what you see here. Mine is standard. Yours may, if you've hit second plus sign 712 recently, yours will also be something like this. Yeah. It's where you may have been doing something else earlier. It's okay. We're going to change it anyway. That resets your whole calculator. Okay. Why does it say error? Okay. If I plug in -3 here, -3 squared is going to be 9. Plus 4 times -3 is -12, so I got 9 minus 12 gives us -3. -3 plus 3 is 0. So if you plug in -3, you get a 0 in the denominator. If you plug in -1, you'll also get a 0 in the denominator. So, look, all right. Okay, so it depends on where your table is starting and whether or not you have changed it to independent or ask, because we're going to change it here in a minute. So it may just be you need to scroll up or down to get to where I am at, because I am looking at -1, -2, -3. There is also a chance that your table has been changed. So if you need to adjust something about your table, so if you're trying to get yours to look like mine, everything that we adjust from the table is going to come from table set, which is right above window. So if you do second window, so second sign and window, it's going to take you to your table setup. And so if you want just like a really general, like basics startup for your table, a lot of times you want your table to start at 0. This delta table, this means your change in table. It's what you're counting by. So if you have changed that, yours might be going up by 5 or 10 or 0.1 or something. It's pretty standard. We just tell it 1. And then both of these are on auto for mine right now. Second window. So if we go back to the table, then mine now doesn't have any errors, but if I go up here where I've got -1, -2, -3, I can see those. So both of these, if I try to find f of -3 or f of -1, I get undefined for both of these. So the function itself is not defined at these points. But that does not necessarily mean that the limit does not exist. Okay? So we're going to use the table to help us find limit values here. So the first one we're going to look at is the limit as x approaches -3 from the left of f of x. Okay? So I said the table didn't matter that much because we're getting ready to change it right now. So the table, notice what I've made the table here for you. When we're approaching -3, so if you think about the number line, here's -3, and down here would be -4, and then over here would be -2, right? So if we are trying to get to -3 right here, and we are approaching from the left, that means we're going to start at values that are below -3, and we're going to try to pick values that get closer and closer and closer and closer to -3. We don't want it to be exactly -3, because what happens whenever I type in exactly -3? I get an error. It's undefined. Okay? So in this case, in my table, I chose -4, which is right here. And then I chose -3.5, which would be about right here. -3.1 would be somewhere around here. And then notice what I'm doing here. I'm getting like 3.01, which is basically there, right? And then you got 3.001, 0.0001. If you needed to, you could get even closer, right? -3.0001, 0.000001. You can put as many O's as you want there, right? So that's the idea of what we're doing. Those values are getting closer and closer and closer and closer to -3, but they're not actually getting there. You can do it infinitely, right? But typically it's not going to be helpful for us to do it infinitely. Now, there's a way we can change our table so that we can just plug these values in. Okay? So, if we do this, we're going to go to second table set. It does not matter what you put table start or changing table on, because we're going to go down here where it says independent, and we're going to go over to ask. Okay, so I'll write those steps down here for you. You're going to do second window. That gets you to the table setup. And you're going to go to independent, and you're going to change it to ask. Okay, so if I go back to my, and make sure you hit enter. Okay, if I go back to my table, it looks like it's broken now, right? I got nothing. But it will let you type numbers in now. So -4, enter, and it gives you that value. So at -4, if I plug in -4, I'm getting -0.3 repeating. Okay, and then -3.5. I get -0.4. Okay, and I'm going to let you guys go through and do the rest of those. I'm going to walk around and see if anybody has any calculator troubles. getting a calculator to work. Let's see. What you got? Okay, go to second table or second graph. Go to the table. Go back to y equals. I think you got some types wrong. Go to your home screen. Go back. It'll take you back. Yeah. All right. Type X and hit enter. Second plus 712. Alright, now type X and let's make sure it's doing it alright. At least a different number now. Go back and type it in again.
Yeah, I didn't find it. I
Because
reset
you had
it.
it typed in correctly.
Yeah, because I reset it, but I guess it still kept the.
Try it again. Yes. Try typing over it then. Try typing in -4. So you got values that I think where you got in your calculator, it may be where you did something but it'll let you type over it. Is it working now, Lucian? Okay.
It's still terrible.
What's she teach, Miss Lowe? I know her. She's really nice. She's
nice, but sometimes she just comes off like,
she's really talented. She's a good musician.
what we
My
take,
husband plays music with her a lot.
we take what she says. That's probably not my idea.
Just go get a different calculator right now, Lucian. Hand me that one. I'll try to.
Literally.
I don't know what it's doing. Yeah, just get, or you can go get one that's not used up here. So, yeah. Okay. All right. So now on this table right here, what do these values look like they're getting closer and closer and closer to? 0.5. In fact, it says it's 0.5 right here, but if you go up here, make sure you're paying attention. If you go up here to this line and you click over so that that value is highlighted, you can see it's not actually negative 0.5. It's just the calculator had to round it because it can only display 4 decimal places right there. Yeah. You may eventually get to where even this big number has to be rounded to negative 0.5. Technically, it's not. It's, 4 point a bunch of nines, but the calculator just can't deal with it anymore. So when you see this happening, though, you should feel pretty confident that this limit as x approaches negative 3 from the left-hand side equals negative 0.5. Now, this does not guarantee it's the case, but evidence supports it. So everything we do from the table, we can't guarantee that that's the case, but evidence is supporting that that's the case. It may just be a difference where you got a newer calculator. It may just be a difference on their algorithms for rounding. But if you go up there on the table, though, it shouldn't actually be negative 0.5. Okay? But what we see is we see our values. Our values are getting closer and closer and closer to that point. But do they ever actually reach that point? They do not, because when we plug in -3, we're undefined. Okay? So that is our limit from the left. Now let's consider our limit from the right. So when we consider the limit from the right, -4 is here. I've really done the hard part for you in filling out this table because sometimes I have a difficult time getting the right numbers leading up to the answer. I do it wrong, like I do 2.01, 2.001, 2.0001. That's not right for this one. You're approaching 3. So if you think about what we're doing here, we're approaching -3, and we're approaching from the right. So we want to pick numbers that come from the right-hand side, ones that are bigger than -3. So right here, we've got -2, -2.5. This would be -2.9. And then you got 2.99, 2.999, and so on. So if we go over here and type those into our table, no. Everything, unless you've reset your calculator, which I do not advise, everything should be the same. All right, so what we're seeing here is we've got -1, -0.6 repeating, -0.5263, -0.5025, -0.5003, and then when we get here, it actually goes to -0.5. However, it's not really -0.05, it's -0.500025. I think I said 05, 0.5. It's got a bunch of zeros before that decimal, but we're seeing evidence that the same thing is happening, right? We're approaching -0.5. So there is evidence that this limit is also -0.5. So if the limit from the left and the limit from the right give us the same number, then we can say that the limit as x approaches -3 of f of x also equals -0.5. If they were different, we would say that the limit does not exist for that last question. So for let's say we got 2 for the first one and we got -0.05 for the second one. Those limits can exist separately. The one from the right and the one from the left can exist. But when it asks us for this right here, which is the limit from both sides, we would have to say that it does not exist for that. But this one exists, it's -0.5. We okay here? All right, we're still using the same equation on this next one, but we're looking at a different point. Okay, so you can leave everything the same. In your y equals is the same, your table's still on ask, but this time we want to approach -1 from the left. Remember, -1's that other spot where we had an error. So if I go over here, you can just type over these. You can probably delete them out if you want. If you'll hit delete, it'll delete them out, or you could just type over them. So if we're approaching -1 from the left, that means that on our number line, down here is -2, -1, 0. We are approaching from this side, so we'd have -2, -1.5, -1.1, and so on. So if we type those in, type that in wrong. -1.01. Okay, now what's happening here? We've got -1, -2, -10, -100, -1,000, -10,000. Does it look like we're approaching a specific number? But what are we seeing? It's getting bigger, or well, not bigger, smaller and smaller and smaller and smaller. It looks like it's just going to keep going that direction, right? So there's two options on this. We can either say that it does not exist, or we can say that it equals negative infinity. Technically, limits do not exist if they equal infinity, because a limit tells you you're stopping somewhere, right? If you go down 77 and the speed limit is 70 miles per hour, that means that you are allowed to go up to 70 miles per hour and not past that, right? It's a limit. It's where it stops. But are you going to see a sign that says speed limit infinity? You're not, because it's not a limit, right? It's not a limit.
India.
Yeah, you would not have a limit if that's the case. So, guys, quiet. We don't have much time. All right, technically, limits that equal infinity also technically do not exist. So what you'll see on this is typically it'll be multiple choice. You will have an answer choice of does not exist, or you might have an answer choice of negative infinity, but you will not have both at the same time. So either one of these are correct answers if you're just writing out the answer. Negative infinity is a little more specific because it gives you more information about what's happening right there. It would depend on your answer choices. That I would not have both of these as answer choices at the same time. So if your answer choices were 2, 7, infinity, or does not exist, you would choose does not exist. But if there was a negative infinity option there, you would choose it, but I would not put does not exist and a negative infinity option there at the same time. Okay, let's see what happens here whenever we approach from the right. So we got 0, negative 0.05, negative 0.9, negative 0.99, negative 0.999, negative 0.9999. Okay, and so you can see basically the same things happening except for we have positives 1, 2, 10, 100, 1,000, 10,000. Okay, so what does it look like is happening here? It looks like we're approaching positive infinity, or we can say does not exist. If it's written out, which it probably won't be on the section, I would accept either. If it's multiple choice, they won't both be there. You're going to pick one of these two. All right, so if our limit as x approaches infinity from the left is negative infinity and from the right it's positive infinity, what are we going to say about the limit from both sides? Does not exist. And for this last part, there are no other options. Does not exist is your only answer. You cannot say positive or negative infinity because they're not the same from both sides. Now, if they were both positive infinity, you could also answer this last question with positive infinity. But since they're different, you have to say does not exist for that last one. All right, real quick, let's look at what this looks like if you graph it. And I'm going to graph it on Desmos just because it's easier to see. What is it? Plus 3x plus 4x plus 3. Okay, so if I graph it at x equals negative 1, what do you see we have? Vertical asymptote. As our x approaches negative 1 from the left, I go to negative infinity. I see that graph going down. As I approach from the right, I go up. But we also looked at x equals negative 3. At that point, it looks just normal, right? But what do we have right there if we can get our cursor just right? I can't get it. Oh, you have a hole in the graph right there. So what's happening is we are approaching that value. We're getting closer to that value, but we don't actually get there. Yeah, you skip over it. Now, when you see it graphed, it looks like there's no hole because you can get infinitely close on both sides, right? It can graph negative 3.0000000001, which when we graph, it's going to look like it is a solid line, but it is not.
If you zoom in close enough, wouldn't there be a hole?
I don't think so, nor do we have time to try right now, but I don't think so. All right, so what I have for the rest of the notes is some more ones that we could use our calculator to find, but instead I'm going to skip over to Delta Math so that you can see what Delta Math is going to look like tonight. You actually don't have to have the calculator because Delta Math, your assignment's going to have it built in tonight. I'm sorry, if it wasn't for the lockdown, we would have had some time for you to work on this today. So I'm just going to run through one here. So these give you a mystery function. Okay? We don't know what f of x is. But it asks us here to find the limit as x approaches 4 of f of x. Okay? And so a number below 4 would be 3. Right? So I could type in 3. So if I type in 3 and hit enter, it's going to give it to me just like a table like we were doing. I don't know what the function actually is. It's giving me some mystery. All right? Give me something even closer to 4. 3.9. Oh, not 33.9. 3.9. Okay? Give me something even closer. Just keep adding 9s, right? What does it look like is happening? All right, so it looks like from the right-hand side, or from the left-hand side, limit as x approaches 4 from the right of f of x. It looks like that's positive infinity. It just keeps on going up. All right? We can clear our table. We also, this one asks us for both sides. So we need to also approach from the positive side. So 5 over here. So 5, give me something closer. 5.4 is further away. 4.5 would be closer. 4.25 is closer. 4.1. 4.01. 001. 0001. What's happening? All right, guys, pay attention because some of you are going to have trouble with this tonight. So limit as x approaches 4 from the left of f of x. This is negative infinity. But this one asked us from both sides. So what would we say? Does not exist, which they use DNE for right here. All right, so this one only asks from the left, so you would only worry about equations from the left. Let me see if it, let me skip. I think it's, I think it's all going to give you limits. If it happens to give you one where it's just like f of 2, you would just type in 2 and see if it gives you a value. Sometimes it will actually give you the value. You just have to be careful, though, because you can have a value where it's defined, but you really care about what it's approaching, not what that value is. So, like, if I try 2.1, 2.01, 2.0001, it looks like this one does approach -2, but it doesn't always. So just typing in that value is not necessarily going to give you what you need to do. So you want to approach from both sides. And then if I try 1.9, 1.99, 1.999, oh, look what happened there. Oh, is it approaching? It does not appear to be approaching negative 2 from the left. Whenever we start plugging, from the left. So from the right, it looks like it approaches negative 2. It does not look like that from this side, so we'd say does not exist. Hopefully that's right. Yes. So if it's both sides, you need to make sure you check both sides on that. Okay. So you don't have to have the calculator or Desmos for this. Actually, this does this for you.